Welcome back to my channel. Today we're going to be discussing the 5 factors that influence temperature and rainfall. We're going to be briefly describing them, we're going to be explaining a little bit, and as a bonus, you get to look at my terribly drawn diagrams. If this video helps you out, please don't forget to like and subscribe. Don't forget to share this with all your friends so they can all get the best geography marks as well. Let's get started. The first factor is the equator. We know that the equator is the 0-degree line of latitude. And as we can see in this picture, everywhere that the equator touches is very, very hot. The equator is some of the hottest places on Earth, and as you go northwards and southwards from the equator, it starts to get a lot more cold. But the question is, why? And there's actually 2 reasons, as illustrated in this picture. The first reason is the distance that the sun's rays have to travel. If you look at the sunbeam hitting the equator, you'll notice that it's much shorter than the sunbeam having to get to the North Pole or the South Pole. And that's because the Earth is round. Because the Earth is round, the part where the equator is quite wide. And so the sun doesn't have to travel as far, which means that the sun's heat will last all the way till it gets to the equator. Whereas in the North and the South Pole, it would have to travel a much greater distance in order to get there. The second reason has to do with surface area. If you have a look at the North Pole and the South Pole, you'll see that the beam gets quite wide. That sun ray has to share a lot of its heat over a much larger area. Whereas at the equator, it's quite a narrow bar, which means that it only has to be in a smaller surface area, which means that all of that heat can be concentrated onto one section of Earth and not shared out amongst a much larger area. Another question a lot of people ask is, what about rain? Does the equator get very little rain or a lot of rain? And surprisingly, the answer is a lot. The equator gets tons of rain because of the heat. The heat evaporates more water every single day, and so it pretty much rains all year round. In fact, a lot of our rainforests are found at the equator. It is hot all year round and it rains all year round. The second factor is distance from the sea. So we know that most places in the world are either next to the beach, so on the coast, or inland, so surrounded by more land. And we're going to be talking about 4 reasons why coastal areas tend to be cooler than inland areas. There are actually 4 reasons. The first reason is that land masses only need as much heat than water to raise the temperature by 1 degree. Inland areas don't need as much sunshine in order to heat it up. And so the ground in inland areas tend to be hotter just by default. Secondly, water is transparent, so the sun's rays go through it, whereas only the top layer of ground is heated. So at the coast, the sun's rays can travel great distances into the ocean, whereas on the land, it can only reach the top layer and then it stops. And so the ground gets very, very hot. Number 3, heat constantly moves in the sea through waves and currents. The ocean is constantly moving, and so a lot of that heat is taken away with it. But in inland areas without that massive ocean, the heat kind of just stays exactly where it is. And number 4, some of the sun's heat is used to evaporate the water instead of raising the temperature. So at the coast, maybe 50% of the sun's rays are being used to heat the land, and the other 50% is used to evaporate the water. But in inland areas, because there isn't a large body of water, all 100% of the sun's rays is being used to heat up the land instead. So, for height above sea level, the rule is the higher you go, the colder it gets. But the question is why? And like you, I have a wonderfully drawn diagram for you. So there is actually 4 steps as to why this happens, right? The first step says the sun. The sun releases something called shortwave rays. Short wave rays are very, very hot. Each wave ray is very, very short and very, very concentrated. And that is the rays that are emitted by the sun. Those short wave rays go all the way down to the earth. The ground can only absorb some of that energy, however. So it takes what it can, and what it can't, it re radiates back into the atmosphere. So, in other words, it absorbs what it can and then releases what it can't. But this time, it's no longer shortwave rays. When it goes back up, they become long wave rays. And these long wave rays aren't as concentrated and aren't as hot. So, as it moves upwards and up, 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 back into the atmosphere, the heat starts to fade away. And so by the time these waves get up to the top of mountains and things like that, there isn't any heat left. And so it's very, very cold. But a lot of people ask me, why don't the shortwave waves just hit the top of the mountain? And the answer is it does. The only problem is that a lot of mountain peaks are quite narrow. There isn't a lot of surface area, and so it can't absorb as much heat as places that are closer to the ground because obviously that's a much larger surface area. So to summarize quickly, the sun emits shortwave rays, which are very hot and very concentrated. The ground can only absorb some of it and re-radiates the rest of it back up to the atmosphere as long-wave rays. These long-wave rays don't have as much heat, and by the time it reaches the top of mountains, it has cooled down. So, firstly, what are ocean currents? Ocean currents are a continuous directed movement of seawater that is caused by salinity differences, changes in temperature, etc. So, these are moving parts of the ocean that are always constantly moving. And let's be honest, there are hundreds of different ocean currents on Earth. Lucky for us, we only have to care about two if you are in South Africa. And those two currents are the Agulhas and the Benguela. The Agulhas current is a warm ocean current, whereas the Benguela current is a cold ocean current. But the question is, why? Why is one warm and one cold? And it really has to do with where it comes from. The warm Agulhas comes from the equator, and we've already just discussed that the equator is the hottest place on Earth. And so the water that is coming downwards from the equator is a warm ocean current. So if you ever travel to Durban, it's going to be nice and toasty in the water. Whereas on the Western Cape by Cape Town, we have the Benguela current, and that is a cold ocean current because it comes from the poles. We know that the poles are very cold, and so the water coming upwards from the South Pole is going to bring cold water with you. So if you're ever in Cape Town, be warned, the water is mighty cold. And our final factor for today, number 5, is mountains. And there are 4 ways that mountains affect the temperature and the rainfall. The first way is called forced ascent of rain. So, in other words, rain that is forced to happen because of wind moving upwards, right? So, this happens when there is a warm breeze. This warm breeze pretty much blows towards a mountain. Some of the wind goes around the mountain, but a lot of it is forced to go upwards. And we already know that the higher you go, the colder it gets. So this warm breeze, and with all of its moist air, starts moving up towards the mountain and starts getting colder and colder. As it starts moving upwards, it forms water vapor, which turns into clouds, and it starts to rain. And so basically, what this rain is called is orographic rain, forced rain. Because the mountain was there, it was forced to rain. The second way that mountains can affect temperature and rainfall is called funneling. If you've ever used a funnel, you know it's like a weird cup shape that starts with a large area and then goes down. Right? Now, this happens between mountain ranges. As you can see in the picture, there's 2 mountain ranges on the side, and the wind is being funneled to the poor little house, which means that that poor guy is going to be getting a lot of wind as it funnels through the mountain ranges. third, we've got blocking. And that's very much as the word says, it blocks the wind. So the cold wind is forced to go over the mountain, and so someone living on the other side of the mountain doesn't have to get that wind. It gets blocked. And then finally, the last one has to do with where on your mountain you are situated. So, depending on where you are, is how much sun you will get. As you can see, the first house is directly in the sun's rays, and so it's going to be very hot. The second house gets some sun, but not very much, and so it's warm. And the other house doesn't get the sun at all, and so it gets very, very cold. But as the sun starts to move across, it will start to change depending on where it is during the day. And that's how mountains affect temperature. And that, ladies and gentlemen, is the 5 factors that influence temperature and rainfall. As usual, if you enjoyed the video, don't forget to like, subscribe, ring the notification bell. And if you have any questions, you're always welcome to pop them in the comment section below, and I'll try my best to get through as many as I can. Thanks so much for watching. Good luck with all your tests and exams. Ciao.